Hi, this is Mr. Ward, and I am doing another video on the MCAS released questions that we talked about in class. And I had a request for me to review a couple of questions from the 2021 released stuff. So I'm going to start with number 10, and I may make some more videos on various selected questions this weekend for y'all, but let's talk about number 10 right now. So we're told the lengths of three sides of a triangle are 3, pi, and square root of 5. Which list shows the lengths in order from least to greatest? So let's think about what we know. We know that 3 well, we know that pi is often estimated as 3.14. So we can be pretty sure that 3 is going to be less than pi. Probably the trickiest question is, what is the square root of 5? So to deal with that, I'm going to do a little illustration right now. All right, so I've illustrated just a little bit. I've written 3, and then I've written pi is approximately 3.14. So those two have a clear order. 3 is less than pi based on that. The real question in this is, what is the square root of 5 close to? Well, a useful thing would be to think about, this is going to be an irrational number. It goes on forever and doesn't settle into a repeating pattern. It's going to be a decimal. But what is it going to be a decimal between? That may give us a clue. So a useful thing would be to think about what the next perfect squares are just above and below it. And the nearest perfect square below it is 4. Okay, so we can say 4 and make it the square root of 4. So the square root of 4 will be less than the square root of 5. And then the next perfect square after 4 will be 9. So the square root of 9 is bigger than the square root of 5. So I'll just set up the inequality like this. And then let's resolve what the square root of 4 is. The square root of 4 is 2. So 2 is less than the square root of 5, and the square root of 9 is 3. So now we've established that the square root of 5 is between 2 and 3. And since it's between 2 and 3, it's less than 3. And so the square root of 5 is less than 3. 3 is less than pi. So we can say 3 pi square root of 5 is wrong because the square root of 5 is less than 3. 3 square root of 5 pi is wrong because the square root of 5 is less than 3. But the square root of 5, 3, and pi, that one works. D doesn't work because pi is greater than 3. So that one's out of place. And in this one, this is out of place. All right, I hope that helped on number 10. I'm going to pause and head down to number 12. So this is the Pythagorean theorem problem here, number 12. Number 12 gives us a right triangle, and it gives us two side measurements. The 7.2, okay, the 7.2 down here is one of the legs of our right triangle, and the 12 is the hypotenuse of our right triangle. So what we need to do is apply the Pythagorean theorem. We're trying to find this measurement. Okay, so it doesn't matter which one of these height or 7.2 gets called A or B. C has to be 12. So we're going to go ahead and work things through with the Pythagorean theorem here. So I'm going to type in here. So I'm going to replace A with 7.2 squared, and that's going to be plus B squared, and that will equal 12 squared. So I'm going to then work out what 7.2 squared is. So let's do that for a second. 7.2 times 7.2, I get 51.84. Okay, so let's go back in here. I get 51.84 for that. Okay. So 51 51.84. Oh, it changed my point size. Interesting. Okay, let's try that again. 51.84 plus b squared equals 12 squared, which is 144. So, and I need to subtract 51.84 from 144 and then figure out what b squared is in order to, okay, so 144 and then minus 51.84, okay, and I think I'm going to have to scroll down to make this work. It's not going to let me. Hang on. Okay, forgive me. I'm a little new to using Cami, but here we go. 144, we're going to need to make that 144.00, and then we do the subtraction. I'm going to have to borrow. That's going to become so I'm going to use the draw tool for this. So this is going to become a 3, and that'll become a 10, then a 9. So that's a 10. That's a 9. Make that actually a 9. Okay, so 10 minus 4. Let's go back to text version, and I can go ahead and finish this. So the 10 minus 4 is 6, and then the 9 minus 8 is 1, and then the 3 minus 1 is 2, and 14, oops, put that decimal in the right place. Start lining this up. Okay, and then the 14 minus 5 is 9. So I've got 92/16. All right, now I need to figure out which one of these options gets us there. So I need to have a 12 squared. So I've got some possibilities. It could be this one. Okay. It's not going to be this one because I don't have a 7.2 squared anywhere. So let's just cross that out. Okay. This one has a 7.2 squared and a 12 squared over here. So it could be this one. This one has a 7.2 squared, but fell into the trap of robotically treating the two numbers as A and B. The longer side has to be C. So let's cross that out because it put 12 squared in for C. So now all we have to do right now is figure out, is the height 4.8 or is it 9.6? Are we doing 4.8 squared or 9.6 squared? So which one of those is going to equal 92.16? Well, we can do a sneaky thing. We can just figure out what's close to 92.6. 4.8 is, well, let's just start off with what is close to 4.8 squared, or what is definitely a little bit more than 4.8 squared. So if we bump round 4.8 to 5, we could do 5 squared. And 5 squared is 25. 25 is way too low to be 92.16 for 4.8 squared to be 92.16. So that's pretty clearly not it. That is not it. So is 9.6 squared equal to 92.16? And it's a good idea to go ahead and figure it out because, you know, we might have a situation where we've made an error along the way. So I'm going to go ahead and do that calculation here. I'm going to put in a text box here. And I'm going to say 9.6 squared, which is going to be 9.6 times 9.6. Now, 9 squared is 81. 10 squared is 100. So I'm somewhere in the right zone for 92.16. So, but I'm going to go ahead and do the calculation. So, okay, I'm going to stretch this out a little bit. Okay, so times, okay, and let's do this. So we'll use the traditional algorithm. 6 times 6 is 36, so I get a 6, carry the 3 up here. So 6 times 9 is 54, plus the 3 is 57. Okay, and I'll bring that over. I'll deal with my decimals in a minute, but I know I'm going to have, well, I'll go ahead and do it now. I know I'm going to have two decimal places. Okay, now I'm going to deal with the 90 times 9, or the 9 times 9.6. So I plug in a 0 at the end to keep track of the fact that I've changed place values. And then 9 times 6 is 54, so 4, carry the 5. 9 times 9 is 81, plus 5, so 86. Put that together, put the decimal place in so we can line up our addition. I'm going to line that up better, line everything up better. Okay, let's go ahead and underline that. Okay, so now I need to underline that. And I'm going to add it together. 6 plus 4, or 6 plus 0, I mean. 6 plus 0 is 6. Ooh, I lost my point size. Let's go back here. Okay. Okay, 6 plus 0 is 0. And what am I saying? Is 6. And 7 plus 4 is 11. So I'm going to have to carry the 1, put a decimal place. 5 plus 6 is 11. Plus 1 more is 2. Oh, looking good. 29.16. And then I had to carry a 1. 1 plus 8 is 9. 92.16. So we do have the right answer here. The answer is C. 7.2 squared plus 9.6 squared is 12 squared. I'm not sure if this section allows a calculator, but if it does, that'll make things a lot easier for you, of course. Now I'm going to pause the video. I'm going to go on to the last question that was requested. Okay, welcome back from my pause. This is number 16, and we have, once again, a couple of parallel lines, and these parallel lines, line Q and line R, are being cut by a transversal that is line C. Now, we can also think of GP as the points G and P forming another line segment that could be extended as a transversal, and that will be useful too. All right, so let's start by seeing what we need to find out. We need to find out the measures of FGV. So FGV, and they've marked that with a question mark. So this is FGV, okay, right here. So we need to find this angle. And I'm going to note that this angle is the same as FGV by using the same color. And the reason it is, and this is also, we won't need that angle. But the reason these two are the same is because they're called alternate interior angles. They're a pair of alternate interior angles. And this angle is also the same. Okay, I'm going to pick a different color for another set of congruent angles. This angle is an alternate interior angle for this angle. So we should now already know that this angle, which is JGP, which is one of our requested angles, that angle is 40 degrees. So I'm going to put a 40 here. So that's 40 degrees. Okay, and we're trying to find this angle and this angle. So we know that JGP, by alternate interior angles, by the zigzag pattern of congruent angles, is 40 degrees. So this is one of our winners. So now we're trying to find FGV, and we're also trying to find GPT. So I'll just underline FGV in red, and we'll pick a different color for GPT. We'll pick yellow. So we're trying to find GPT, which is this one. Okay, I didn't pick yellow apparently. Okay, This right here makes 180 degrees. So from here to here is 180 degrees, which means 40 plus GPT has to be 180 degrees. So GPT is 180. I'm going to undo that if I can. Oops. So this here is 180 degrees. So this is 180 minus the known angle of 40 degrees. Okay, and that's just going to be 140 degrees. So we now have that angle. So that's going to be 140. So that's, we're going to find 140 in here, make sure it's labeled with GPT. So we have a second one. So that one's taken care of. Now we just need to find FGV. And there's several ways to do it, but one way is to notice once again that we have 180 degrees. This is a straight angle, and that 180 degrees contains 40 and 73 degrees and some unknown. So we can just, oops, that was not what I was trying to do. Thank you, Cami, for misunderstanding me. So we can just go right here, and I'm going to say FGV is 180 minus the sum of 73 and 40. So 73 plus 40. And 73 plus 40 is 113. So we're looking for 180 minus 113. Okay, so 180 minus 113. I'm going to switch to text box because I just can type a lot faster there. Okay. And so 180 minus 113. And I'm going to be borrowing from the 8. That'll become a 7. That'll become a 10. 10 minus 3 is 7. And then the 8 became a 7. So 7 minus 1 is 6. And that is my angle. So we have 67 degrees for FGV. I hope that was helpful. And you just really have to pay attention to, you need to know about how the transversals work, how they make this zigzag pattern of congruency. Okay. This is a zigzag pattern going on here as well. And you also need to take advantage of 180 degrees because that gives us what's left over of 180 degrees here when we had 40 degrees. You could also have used the triangle here to help you. So 73 plus 40, again, is 113. Triangle has 180 degrees contained in it. So this angle here would have been 67 degrees. And then if you knew that the alternate interior angles would be the same, then that would also give you FGV. All right, I'm going to go ahead and stop.